using the GCF. Okay, using the greatest common factor. So first, what is a greatest common factor? Factors are the numbers that multiply together to get a certain product. So for example, 2 times 4 is equal to 8. These are factors, and this is the product, right? So product is the answer to a multiplication problem. All right, now greatest, so it's the biggest, the largest number. Common, they both have to have it. So for 8, 4 and 2, and also 1 and 8, those are all factors of 8, right? But when we're talking about a common factor, we're talking about the factors of two numbers. So the ones that they both have to have it, it's the biggest one of them. And a factor is the number that can be basically divided out of both numbers. Okay, so for 6, what are the factors of 6? You've got 1 and 6 and 2 times 3. These are all the factors. Okay, what are the factors of 24? We've got 1 and 24. We've got 2 and 12. We've got 3 and 8. We've got 4 and 6. These are all the numbers that can multiply together to get 24. Now, which one do they have in common? And it's the biggest one. Okay, so I would start with the largest factor of the smallest number. So they have in common 2, they have in common 1, they have in common 3, and they have in common 6. And what is the biggest number out of all those? 6. So 6 is the GCF of 6 and 24. Okay? So the answer is 6. All right, next slide. So what is the GCF of 12 and 28? So you're going to go through your multiplication tables and think of it as division. Divide by 1, 1 and 12. Divide by 2, 2 and 6. Divide by 3, 3 and 4. And that's it. We won't divide by 5 evenly or 7. Okay. So then for 28, 1 times 28. 2 times 14. 3, you could check it by saying 28 divided by 3. What is that? And you pick up your calculator and boop, boop, boop. And it's not a whole number, so you're not worried about it. And 4 and 7. Okay, now what are the ones that they have in common? They have in common number 1. They have in common 2. They have in common 4. Boom, 4. 4 is the highest number that they have in common. The GCF is 4. The GCF of 12 and 28 is 4. Okay, so you understand what we're doing here. What about between 20 and 50? So again, you're looking for what is a number. What is the largest number that they both have as a factor? So write your little list of factors. We got 1 and 20. We got 2 and 10. Notice how I just start dividing by 1, by 2, by 3. 3's not going to work. What about 4? Yep, 4 works. 4 and 5, and then 5 and 4. Okay, so now when it starts to turn around, when I get the next number I'm going to divide is already on this side of the list, I know that I've got them all. Okay, so now with 50, we got 1 times 50. Now let's divide it by 2. So 50 divided by 2 is 25. 2 times 25, that's like a little math family. I think that's what you call them. Okay, can't divide by 3. What about 4? No. What about 5? Yes. 5 and 10. 6, no. 7, no. 8, no. Okay, so we've got our list. Now, what do they have in common? To make it go faster, you could start with the largest number on the smallest number side. Ooh, that's kind of hard to explain, huh? So start on this list. Do they both have 20? No. Do they both have 10? Yes. Okay, so 10 is the GCF. of 20 and 50. Okay. Whoa, what about variables? Oh man. Well, let's think about what is being multiplied here that they have in common. We've got x and x and x and y. And over here we've got x and y and y. So this whole thing, these are all the factors, 1, 2, 3, 4. These are all the factors that make up x to the third y. These are the factors that make up x to y squared. Now, what do they have in common? Do they both have an x? Yeah, they both have an x. This guy's got an x, this guy's got an x. Well, this one has 2. Oh, but this doesn't have 2. So you can only factor out or take out, divide out what they have in common. Remember, it's the greatest common factor. Okay, so no more x's because this guy ran out of x's. But this guy's got a y. This guy's got a y. Can I take out both? No, this one only has 1. So the greatest common factor of these two terms is x, y. That's the largest thing that you can divide out of this and divide out of that. Okay, I know that was a big leap from numbers that you're really comfortable with to all of a sudden variables. So let's look back at what we did. However many this guy has of each variable, and this guy has the same amount, whatever, let me start again. So when I expand it out, it's easy for me to see what's being multiplied here. 3 x's are being multiplied and a y. Over here, I've got 1 x and 2 y's. So what is the most amount of x's that I can take out of both sides? Okay, what is it that they agree upon? At least 1 x. What is the most amount of y's? At least 1 y, and that's why my GCF is xy. Okay. Now let's talk about, so that was all talking about GCF. Now we're talking about factoring, okay? And to explain factoring, first let's do something we're comfortable with, we're familiar with. Go ahead and simplify these, distribute that out. So when we distribute the outside term to the inside terms, we have 3a squared plus 7a. We have negative 2m to the third, and then that was the first time. Now multiply the two numbers, negative 12, and there's 1m times another m. Remember, we add, when we're multiplying, we add the exponents of like bases. And anything times negative 1 is just flip its sign, right? So negative 2 times negative 1 gives us a positive 2, and the m just tags along. Okay, so what are we doing here? We're distributing. Okay, so that's going to be 5x squared y. And then to the second term, negative 10x. And how many y's now? 2 of them. Okay, so what we did is distribution, right? Factoring is the opposite of distribution. If I give you this and I say, tell me that, whoa, I know it's hard, it's tough. But what we're doing, factoring, is we're doing basically the reverse of distribution. So you're looking at these two terms and you're saying, what do they have in common? Well, the numbers don't have any common factors, so that's out completely. But this one has 2 a's and this one has 1, so I could at least take out one of the a's, and that's what it looks like when you do that. Okay, let's go to the next slide. Okay, so factoring is the reverse of distributive property. Ask yourself, what is the most that you could divide out of all the terms? Like all of them. Okay, so this guy doesn't even have an x, so I know I can't take out the x. But this term and this term, what could we divide out of 3 and 12? Think about what are the factors of 3 and what are the factors of 12? Well, the factors of 3 are 1 and 3. That's it. The factors of 12 are, so is 3 a factor of 12? Yes, remember 3 times 4, right? So what we're doing is we're going to divide out. We're going to show what we're taking out on the outside. 3. We're dividing out the 3. And then what we end up with is 3 on the outside. Now when I divide out the 3, I have just x left over. And when I divide out the 3 here, I've got 4 left over. How do I know that this is right? You can check by redistributing. So is 3 times x 3x, and 3 times positive 4 is 12. See how I got, when I redistributed, I got the same answer that I was starting with? So that shows me that it's right. So this is our answer. What is the GCF? Getting a little messy here. There we go. So the GCF is 3. Okay, that's the greatest common factor of those terms, but this is how we show it. This is what iExcel is going to want you to do too. When you factor it out, what does it look like? It looks like this. It looks like the reverse of distributive property, like what you started with when you do distributive property. So what number can we take out of both of those numbers? Well, they're both divisible by 5, right? Do they have any variables in common? No. So divide out the 5, and what are we left with? Just, see how we're left with just an x, plus 30 divided by 5 is 6, and then couldn't get rid of the y, so here we go. This is our answer. Looks like the reverse of distributive property, right? Yeah, okay. Okay, out of these two, let's just look at the numbers at first. Can you divide out any common numbers? You might be looking at this and be like, yeah, those are both divisible by 2. I could divide out 2 and I could divide out 2. Yes, but is there a bigger number you could divide out of both of them? Hopefully you're saying, yes, Miss Kenyon. I could divide out at least 4. I could divide out 4. Okay, so you want the highest number you can divide out of them. Then how many y's can you take out? Well, he's got 2 and he's got 1, so we can at least take out 1 from each of them. Okay, so now I have 4y on the outside, and then 4y squared divided, so the 4's go away, right? And then I'm going to be left with just 1y. Then minus sign. And I'm going to divide 24 by 4, that gives me 6. And I divided out the y, so that's it. That's it. Now remember, if you're worried that you're getting it wrong, you can do distributive property again, and you'll get back to this, and so then you didn't do anything wrong. All right, 8m plus 36n. Well, they don't have any variables in common, so let's think about the numbers. Well, of course, they're both divisible by 2, right? Both of these are divisible by 2 because they're both even numbers. But what else are they divisible by? You can make your list. 1 times 8, 2 times 4, that's it. And then with 36, you got 1 and 36. You've got 2 and 18. You've got 3 and 12. You've got 4 and 9. You've got 6 and 6. Okay, so then look at this list of numbers and this list of numbers, and what is the largest number they both have? So the largest number they both have is 4. So that's what we can divide out. Can't divide out any variables because they don't have anything in common. So 4 on the outside, and that leaves me with 2m plus 9n. Now, you might be sitting there going, yeah, Miss Kenyon, you're going real fast through all those factors, but I don't know my multiplication tables that well, and I'm a little embarrassed about it. How can I get around that? Okay, student, here's what you can do. You can go to Desmos, and you can click on the table, And you can first you have to do y is equal to, what number do you want to know about? 36 divided by x. And then that's going to give you that table of factors. We've used this before. Remember, we were doing this back when we were simplifying radicals. Remember? Yeah. Okay. So I'll show you that in a minute with another problem. But look at these. They both have ones. Well, you can't really divide out one, but they both have an A. So let's divide out an A. And so when I divide out the A, I just have B left. Okay, what goes on the outside? The thing that I was dividing out. When I divide this, everything goes away. So do I just leave it like, no, okay. A over A is minus sign, because I'm carrying that down, 1, right? Because when we multiply this, I have to get back to what I originally had for if I was doing a check, okay? So there you go. When you divide something by itself, it's 1. It's not nothing. Okay, now divide, there's no numbers. I've just got 1 and 5, and for 13, it's 1 and 13. They don't have anything in common other than 1. All I can divide out of these is a 1. So when there is no GCF, it is prime. This is prime. Okay, that is our answer to that. That's prime. Okay, in the trash, and all right, here's when it might be a good time to go and show you how to use Desmos to get those factors. So I'm going to escape and click on Desmos. I want to know about the number 18. Okay, so I come over here to Desmos and I type in y is equal to 18 divided by x. And then I have to click on the wheel to get the table. All right, now I'm looking down my list, and I come down here to where the 2 is. I put the cursor there, and I hit enter, 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 and that's giving you your list of your factors. So your list of factors are 1 and 18, 2 and 9, 3 and 6, and then it's restarting here. So that's really the end of it. Now go and look at what was the other number you wanted to know about. 12 was the other number you wanted to know about. Okay, so now I'm going to do a second. Y is equal to 12 divided by x. Now, it would be better if you just got used to your multiplication tables than having to do these tables all the time. But it's an option. It's a way to do it. Okay. So there, now I've got a list for both. I've got a list of 1 and 12 and 2 and 6 and 3 and 4, and then that's going to restart. And then here's my list, 1 and 18, 2 and 9, 3 and 6. In my opinion, I'm wondering if you could tell by the graph if that would help you. Because I'm seeing 6. See how they both have a dot at 6? I'm looking for places that they both have a dot. So they both have a dot at 6. And any other ones? Nope. So 6 is your greatest common factor. So this is how you could use Desmos to help you. You could look at what is the biggest number on the y-axis that they both have a dot at. Or you could look at the tables, okay? Or you could just learn your multiplication tables. Come on. Okay, now let's go back into presentation mode so it's bigger. And most of the numbers are not enormous. So if we were just going to do this, I think this is a better way to do it, honestly. Using Desmos is a little bit of a crutch sometimes. Okay, so that was my list for 18. Here's my list for 12. And I see, yes, indeed, they both have a 6. So I'm going to divide out of this a 6. But what else can I take out? What else is a common factor? Well, this guy's got 4 x's and this guy's got 2, so I can at least take out 2. And that's going to leave me with 6x squared on the outside. So this is the greatest common factor. And then what are the leftovers? When you divide out the greatest common factor, what are the leftovers? So 18 divided by 6, that gives you 3. X to the 4th divided by x to the 2nd, that gives you x squared. And then we've got a minus sign. 12 divided by 6 gives you 2. All the x's get used up, so you just leave it off, right? And double check yourself. 6x squared times negative 2, that gives you negative 12x squared. So you did it right. Okay, so I showed you how to use Desmos. I think it's much easier to just make your little tree. And you might not even need to make a tree. You might just be like, oh, the biggest number that they have is 4. And you'd be right. But I'll make the tree for you. Right? And then 20 is like 1 and 20, and 2 and 10, and 4 and 5. And so 4 is the biggest number that they both have in common. What about variables? Yep, they both have at least one b. So we can take that out. So 4b, and then 12 divided by 4 gives you 3. A, and then this had 3 b's, and I'm only taking out 1. So that's b to the 2nd power. See how the exponents unit that we just did is helping you with this unit? Super important. So plus 5, and then b divided by b is going to be no more b's, right? They would cancel each other out. And so here would be our answer. If that is the part that I think people are going to get stuck on. They're going to be like, wait, what happened to? Yeah. So then you could, to check yourself, you could redistribute. Yep, that's 12ab to the 3rd plus 20b. Is that right? Oh, yep. Sure is. Okay. Okay, more variables. Now we're dealing with variables, different variables. Okay, I look at all the terms, and then look at this. This is the trick. Look at the smallest one. Look at the smallest one and see what it's got. This guy's only got an x. So am I going to be able to take any y's? No. These are 3 terms. The most I could take out of this, you have to take something out or it's already prime, okay? So you can at least take out an x, and that's all you can take out. So I have x on the outside, and then the leftovers. If I take this and divide out an x, I have x squared, y squared, plus, just copy and paste the plus, right? Take out one of those x's. And something over itself does not disappear. It is 1. So make sure you see that. Okay, over here, don't look at this guy so much as look at this guy. What does he have that you can take out? Well, he has an A. Everybody else has got at least one A. Now, numbers-wise, look at the smallest number. We can divide out 5 out of each of these. So let's take out 5 and an A. So this is the most you can divide out of all of the terms. And then it goes on the outside, and then you put the leftovers on the inside. Okay, the 5's canceled out, and one of the a's, so you have ab squared. Copy and paste the plus sign. 10 divided by 5 is 2. The a's cancel out, just b, plus 5. Oop, the a's canceled out, so that's it. Okay, you can always pause it if you want to take some notes. Okay, which one of these is prime? You are looking for the one that you can neither divide out any numbers. They don't have any numbers that are in common, no common factors, and they have no common variables. And you'll have to answer that on the pair deck. Here is a recap of the rules. So look at the coefficients first. That's the numbers. See what numbers you could divide out of all of the coefficients. A variable must be common to all the terms. So that means every term has to have that variable. If a variable is common to all terms, take the one with the smallest exponent and then divide all the terms by the GCF to get the remainder in the parentheses. So you would have your answer if we had a problem like 5xy plus 10x squared minus 15x. So we're going to take out the most we can out of all of them. Look at the coefficients. Okay, this has 5 is the biggest number that can come out of all of these. Then, are there any variables that they have in common? Yes, they have an x in common. Go with the smallest exponent. Then we're going to put 5x, the GCF, on the outside and leave the remainder, the leftovers, on the inside in parentheses. So we've got just a y plus 2x minus 3. Done deal. That was following the directions. Now it's time to do your homework. Okay, so this was a 26-minute video, and you need to do the pair deck, assignment, and do AA2, and you got to get at least a 60 on your SMART score. That is the end.